So in this presentation, which is framed in the also a tutorial that we're giving in the Human-Robot Interaction conference, is called Robo Ludens. It's basically a series of talks that we're giving in game design techniques applying in human-robot interaction. Today, I'm going to be talking mostly about the taxonomy itself, and I'm going to be covering other game design aspects and fundamentals, but mostly trying to get focus on the taxonomy we did, which I hope is going to be useful for the audience. So I'm going to be mostly talking about robots, game and game design techniques, and some of the user experiences that are around this emerging convergence. And we kind of start, it's very hard to start talking about games and playful activities without actually trying to bring a wider definition of what play means. And you know, the best way to do it is through something that is called the Robo Ludens Manifesto, which is something that a Professor Huizinga from the Netherlands did some decades ago, and he was trying to basically deconstruct this aspect of playing. So he defines play as an activity with 6 main components. The first is it has to be free. That means there's no obligation to play the game. It has to be certainly separate. That means the limits between the space and the time in where the play is taking place, they should be very well defined. It has to be uncertain. So you cannot necessarily predict accurately what is going to happen in that specific playful activity. It has to be unproductive, so it doesn't create any type of guilt or wealth among participants or players. It has to be governed by rules, so the rules should be certainly well defined, and rules are basically conventions and laws that are regulating these activities. And in a certain way, and all of this is happening in your brain, and you know is boosted by your imagination, but it has to be highly rooted on any sort of artificial conflict that we create in our brain. So once we define play, then all of this is well defined in this book called the Robo Ludens, which is basically an anthropological narrative around the study of play elements in all the human culture. But now we can define what a game is. So I've got like many different definitions, and I think that this was the one that was probably more related to the type of research we're doing. A game can be defined as a structured experience consisting of a goal, rules, a feedback system, and voluntary participation. All of this built around an interconnected system. And that interconnection is certainly important, as we will see in the taxonomy, to actually be able to differentiate what is a game and what is not a game. What can be, for instance, an interactive narrative, an interactive storytelling, what can be all the types of media that are also very valuable, especially for the human-robot interaction community, but they are not necessarily a game. And that's one of the initial insights I got when we were reviewing all different papers, was that different people were trying to define different activities as a game when they are not necessarily, they don't necessarily have the aspects of a game. We have been certainly very intrigued throughout history about how machines can get certain level of intelligence to actually play games in an intelligent manner with us as as peers. And here you can see what is called the mechanical turret, was an invention that people working in automatization back in the last century, they were trying to certainly fake a human. In this case, it's like a humanoid trying to play chess. So that was a trick actually that was intriguing people in different places in Europe, in which what all of this trick was about. It was one chess player playing under the table, so that person was able to make really good movements and to play in a really smart way chess. But while all the people were saying that this human was the one playing, so everyone was kind of like super excited to see this when what actually was a fake chess player. And that's actually one of the earliest probably cases in which there was a lot of people fascinated about this possibility of the machines having a certain level of intelligence to be able to interact and to play games just as we humans do. So what we are trying to do in this research is basically trying to get two fields that are not necessarily talking in a very natural way, and get them together and try to see what are the converging elements. The first field is the field of game design, which from my own point of view, my own definition, is the art of deconstructing playful or ludic activities into fundamental aspects that can be defined based on different frameworks to basically create a fun and enjoyable experience for players. At the same time, we're trying to see in the human-robot interaction side, how we can apply some of these game design techniques to create playful robots, to create playful activities using, in this specific case of this taxonomy, are physically embodied robots. So I like to define, again, I'm not coming from the field of human-robot interaction, but I'm trying to also define this in a similar way. And I believe this the art of deconstructing the human behavior and attitudes when interacting with robots to certainly decide them in a way that are more acceptable by people, by human beings. So when I arrived to start doing research in the human-robot interaction side, I noticed that there's plenty of very nice examples of how to use games empowered by robots or robots empowered by games. But I found, I would say, three main limitations called, the guidelines to design these games are certainly are not existent, or they're not so clear here and there. And there's not necessarily a categorization that can describe which are the fundamental aspects and elements that one should consider when doing, HRI experiments. On the other side, we have, a lot of different good examples, but there's something I call the playful robots diaspora, which means there's a widespread, there's a dispersion of the different game examples using social robots. They're used basically, or every individual research laboratory, they're using different approaches, and there's not a consensus on how to document those and how to, what can be, even in the definition of what a game is, there's already a diaspora there. So it's very hard for a young researcher to try to come here and start, creating upon what is there, just because they're not necessarily, or couldn't find formal definitions, which is something that is already kind of like well described, for instance, in the field of game design, which of course is it has more decades of development than the field of human-robot interaction. I also couldn't find a specific papers or literature describing those interrelationships between the game and the robot. So how they are interconnected, and how by creating a system empowering a robot, with specific playful activities, how this can be somehow beneficial from an interaction point of view to the players or the target population that the researchers are targeting. Because of that, so we decided to create a taxonomy that can bring those fundamental aspects and elements, and can help us to categorize those elements in games and human-robot interaction. So we started by just trying to make some definitions about, what is a game, what is an activity, what are playful scenarios, and how these physically embodied social robots can actually play a specific role on adopting game and game design techniques. Then we were searching between, we did different literature reviews into single versus multiplayer games. And, we found plenty of, interesting and good examples about using social robots interacting in a single player manner. So there's only one human player playing with or in collaboration with the robot. But we noticed that a multiplayer scenarios were not so popular, but at the same time, a lot of the aspects that you can cover in a multiplayer game can be actually or transversally applied to single player games. So in some way, in terms of game design, designing a game that is used by multiple users is certainly more complex to, once compared to a game that is only designed to be played by one single player. So we thought that maybe going through the more complex scenario can be a little bit more useful once we decided to try to apply this to single players. Then we did a scoping review of different papers, and I'm not gonna, just for the sake of time, I'm not gonna go through all the different papers and all the different, description we did. But in a sense, we found 15 papers involving one or sometimes more robots and at least 2 human beings interacting in specific experiments or prototypes. And then we did an iterative design process in which we were exposing initial designs of the taxonomy to our research laboratory and to some other experts, and we were, adjusting the taxonomy. For the eligibility criteria, we were trying to use, games instead of simulated tasks. So again, there's plenty of definition of what a game is, and we were trying to go through those specific activities in which people were having specific rules, where all the system were certainly interconnected, where the robot or the game, they were actually sensing the player's performance, and there were some specific feedback mechanism in which the players would be able to notice about their own performance or the performance of the other players. So although sometimes the papers, they were not defining those activities as games, so based on that specific definition I just gave minutes ago, we were assuming them as games. So we also try to include only physically, in this case, social agents that were physically embodied. So we were trying to avoid the virtual agents just because the interaction between, a physical embodied robot and a virtual agent when it comes to games can be very different. And that's an entire topic for discussion outside this scoping review. Also, we went to multiplayer gameplay rather than single player. And we tried to cover also games that were already doing some experimental research. And some of them were game design concepts that were kind of like interesting and not necessarily, they didn't have like a lot of background in terms of, testing with participants or with players, but the concepts were still very interesting. Some examples of the studies that we found here and we use for this taxonomy, or for instance, there's one example of Forehead playing a collaborative. Forehead is this head-like, human head-like robot that uses a back projector to display a lot of different facial expressions and emotions. And Forehead was here playing a collaborative problem-solving game called Desert Survival. So people would have to basically sort it out and prioritize certain elements that were on the table based on this artificially created situation in which they have to go to a survival situation. We got also examples like the Now robot tutoring children to collaborate in a puzzle game, which is called Pangram, in which they have to basically place individual pieces to create a specific shape that is initially given. Also, we have examples like, for instance, the Casper robot, which is here trying to playing an imitation turn-taking game using postures. So you can see the Casper is wearing a Wii mode. So every time the Casper is doing a movement, the players were also wearing the Wii mode, so they would be able to sense the specific postures of the participants, and they will be able to provide a specific feedback when the players were doing specific postures. So these are only 3 of the examples, but we have an entire deck of 15 different games involving, again, one, sometimes more than one robot, physically embodied robot, and at least 2 human players. So we actually this taxonomy was accepted to be published in the Transaction of Human Robot Interaction, and is basically impressed. So it's going to come in the next issue. If you are interested in this research, I can also give you a proof, a preprint proof of the paper, the entire paper. Now I'm going to give you here is basically an overall view of the taxonomy. So we will start with the taxonomy, and we basically made a distinction between robots and games. So we will see in the entire taxonomy, we'll see some aspects that are coming from the robot, some aspects that are coming from the game, and then at the end we will see where they are converging, where is the the interrelationship between some of the specific elements. So the first element of the robot is called the role. So what is the role of the role? So robots can play different roles when playing or interacting with human participants, mediating gameplay. So we have in total 5 different roles that the robot can play. The robots can be an active player in the game, so they can even cooperate, collaborate, or compete against participants. To clarify here, there's a difference between cooperation and collaboration. In collaboration, you actually have to work together with the other players to achieve this, the game goal. So you actually have to kind of like talk and interact and do, more than just divide and conquer. The cooperation is in which you certainly have to achieve a goal, but in order to achieve that goal, you don't have to, work closely with the other player. So we found a lot of interesting examples where robots were actually playing as active players in the role. So we also have the role of trainer, tutor, teacher, which we managed to kind of like put them together here just because the robot in this case is kind of like guiding participants to do a specific task. So the role of the robot here is just kind of like teaching, tutoring, or training participants into doing, interacting in the game. We also have a role when the robot is mediating the interaction and is moderating the gameplay, so the human participants can play the game and they can ask the robot what to do next, for instance. We also have the role of the robot as performer or executor, and in this specific case, we found that the teleoperation is probably the most common scenario where people prefer to use robot as executor or performance when they have different interfaces and the robot is capable to interpret those actions required by the human participants, and that is part of the gameplay scenario. And also, robots can be bystanders. So we didn't find a lot of examples of robots as bystanders, but they can also be only assisting, it's just being they're witnessing the gameplay, and that sometimes can create specific behaviors on human participants. Second category with the inside the robot branch is the appearance. So we found very various and diverse different ways in which people, and in this case, that roboticists were designing the robots and using the robots. And, from a gameplay perspective, the morphological characteristics and features of the robot will certainly help to shape the creation of the specific game elements to actually create more suitable experiences depending on the type of game that you're planning to create. So we got this categorization of zoomorphic and anthropomorphic. Some of them were very original or artistic, Some of them were only functional robots, so they were only having a specific function, and all the shape was, along that specific function. For instance, robotic arms. Some of them were mechanoid, so the aspect was super mechanic, and some of them were actually a little bit more humanoid, like raw, like Now or Pepper robots. So in this category, we identify that sometimes a robot can be original or artistic, and at the same time can be humanoid. So this is not discriminative. So one category is not necessarily a unique category that a robot can have. So a robot, at some point might have different aspects and appearances, and they are not discriminative in that sense. The final category in the branch of robot is called motor abilities. So, which are the motor capacities? In this case, the physically embodied robot has to interact with participants and to interact with sometimes the game elements that were in some of the cases tangible game elements. So they were not, for instance, tables, screens, or tablets that you can just touch. But some people were actually using tangible elements that you can play, like board games, tokens, cards, or things like that. So this capability that the robot might have to move is certainly a unique feature of physically embodied robots, and it helps a lot into this. It facilitates the interaction when the robot is, for instance, moderating the interaction. The robot can point out to something that is physically located in the space. So we have here two main. So this was one of those categories in which we were having a lot of different discussions about the different ways that the robots can have motor abilities, but we decided to just enclose them into two. Robots that are in place movement. That means, like, there's sort of, for instance, when the Now robot, for instance, has the torso part of the Now that you can use. So that's a robot that can do in-place movements. A lot of the robotic arms are also in-place movement. There's all the robots that can move in a space. So they actually have wheels, or they have legs, and they can move around. And again, all of these capabilities of the robot might certainly shape the interaction with the game. So until here, we have three subcategories related to the robot category in the Robo Ludens taxonomy. The second subcategory, the second branch, is the game aspects, which are those categories that we need to consider when designing games with robots. And here we have a set of, I think it's 1, 2, 3, 4 specific subcategories. The first one is actually the one that, from my perspective of game design, is the most exciting. So, and this is, which are these game mechanics? And again, a game mechanic is mostly the core element of the game. So once you remove all the technological aspects, once you remove the narrative, once you even remove the aesthetics of the game, what is there? What is the main component that is that is going to generate the action reaction between the human player and the game? So it's basically the actions that the participants or the players, they have to perform in order to provide an ongoing gameplay in the game. So here, what we found is basically a list of 5. I mean, there's plenty of different game mechanics in the space of game design, but I found these 5, the ones that are most popular among human-robot interaction researchers. So imitation game. So most of the time, the robot was asking participants to imitate a specific movement that the robot was performing beforehand. The example of the Casper robot, when Casper was there wearing, the specific sensor, and the robot was doing a specific posture and asking participants to move accordingly. And once the system, in this case Casper, was detecting that the players were moving into what was supposed to be the desired posture, that's a very classic example that I found. Most of the games were actually going through the imitation category. Then we have the guessing, in which we don't necessarily need to do a lot of involved posture, but in most of the guessing is speech. There's a lot of talking between the robot and the human players, and the players, they have to guess something correctly. So they use a lot of natural language processing here, and all the capacities that the robots might have to recognize the speech as a way to interact and provide useful feedback. The third game mechanic is called task completion, and again, the tasks can be even cooperative or collaborative in this case. And in this specific game mechanic, the robot was asking participants to complete a specific task depending on the objects, the specific objective of the game. In the Tangram game, for instance, something. Can you guys hear me?
Yes, now yes. You
Okay.
you froze for a moment.
Yeah.
Okay. Yeah. Sorry. So coming back, task completion. So the robot is asking participants to complete a specific task, and the players they have to complete that. Teleoperation, again, very used in robotics, and I think that's one of the most fascinating, I will say, and very specific game mechanic that you can use in a robot. So the possibility that you, as a player, can have to embody it, physically embodied agent in real life is something that you cannot do with humans. So you cannot embody yourself into another human. And even though when you're using, I don't know, all the game media like virtual reality or others, the possibility of embodying something that is real and tangible in the real world, that's something that is certainly fascinating, and a lot of designers were using that. And the final one is called reaction time. So time is actually a very simple aspect that you can use to create a game mechanic in which you put timers. You can put, only the presence of a timer can change the entire dynamics of the game. So a lot of researchers were using that as a way to certainly create this pressure or gameplay among players to complete a specific task under a specific range of time. Second category is called the application area, and here we found conventional entertainment, educational training, and assistance areas in which the different games that were created with the robots were using, or they were just kind of trying to target. So a lot of the examples we found were in the field of training and education. When it comes to kind of like healthcare, the assistance sometimes is also one that is very preferred as education area. So I found some interesting examples in which, for instance, the Now robot was used as a way to facilitate this awareness in children suffering with cancer, for instance. So the robot was able to create some interactive storytelling with the participants, and they were, wearing some specific customs, like nurses or doctors, and the children were asking questions to Now about the disease, and the robot was capable to manage a certain interactive narrative and interactive storytelling and gameplay with the participants. Third subcategory in the game branch is called sensing capabilities. And in these two categories, you will see it's not that easy to certainly recognize what is part of the game and what is part of the robot. And we will try to clarify that a little bit later on in this presentation. So the sensing capabilities means, okay, which are the capabilities of the game and the robot. They both can have to sense the performance of the players while they're playing the game. So in order to create a game, you certainly need a closed loop system. That means the game should be aware of certain level of performance of the participant. And once the game is detecting that performance, that means detecting the action that the player is doing, that you can, create or react. The game can react accordingly and adapt the gameplay and kind of like render again the next frame. So in the field of video game creation, that's called a game loop, and that's something that is crucial here to have, and to have certainly games and robots that are empowered with sensing capabilities. So of course you can sense a lot of different things from human participants, like the gesture, the posture, the facial expressions, the speech, the touch. A lot of the robots, and I found that very clever from the HRI community, using screens, to basically get the inputs from the participants. So on a lot of the scenarios, they were using small tablets, but a lot of them, they were using large surface. So people were basically getting the input of the game, and then the robot was aware of those inputs and was modifying the gameplay accordingly. Some of the examples, they were also tracking the gaze of participants and trying to see if they were or not paying attention to the specific instructions, and then following the gameplay accordingly. Also, you can measure how the proximity, how spatially how participants or players are locating in a spatial environment, and then trying to play a little bit with that variable to create specific rules based on if the players are close to the robot or they are far away from the robot or elements. The final category is called the feedback modality, and that's basically how the robot and the game, how they are communicating the participants' performance when playing the game. So what is the game progress? Which type of technology you can use to provide that type of feedback. So we found here a set of 6 specific ways in which the robot, in this case, will be able to express the game progress. You can use a screen base, so the robot's connected through screen. The robot can actually make some sounds or can say specific phrases related to the gameplay. You can use haptic. I remember there was a specific scenario in which they were using like in a small tabletop robot, and people were grasping specific or grabbing a specific element, and the robot was vibrating at the time that the first person was kind of like clicking or kind of like pressing a button as a way to use the reaction time as a game mechanic, but as a way to provide the feedback about who was winning that specific round. Robots can also detect your facial expressions and try to play with that in order to create more adaptive gameplay. Same thing for the body language and light. So the robots can, for instance, in the case of forehead, the robot can do a lot of different facial expressions that are related to how people were doing or how people were prioritizing, for instance, the tangible elements in this survival game. And at the end, very simple, like I think Miro robot, which is like a small donkey, rat, or rabbit, I don't know. That's the small robot. It's very nicely designed to provide some lights when there are things that are nearby or there are some specific emotions and the ears are coming down, but at the same time the lights are lighting in very different colors. So the taxonomy at glance is like this one. So you can see on the top, you have the robot side, robot role, motor abilities, and appearance, and in the bottom part you have all the game aspects, like the game mechanic, the application, the sensing capabilities, and the feedback modality. There's a relationship between the different categories, so it's not like only the game can have a specific sensing capability or feedback modality, or only the robot can have it. Actually, the most interesting designs that I found, an example that I found in which robots were certainly merged and interconnected pretty well with the game, was when they were sharing things like the sensing capabilities and the feedback modality. So when the game itself was providing a visual feedback, but at the same time the robot was actually saying something else. So the robot was expressing something with the physically embodied elements that the robot might have, I don't know, arms or like the legs or the facial expressions. So these two specific, the sensing capabilities, the feedback modality, is something that is commonly shared among these things that are intrinsically connected. So playful robots can actually combine some of the elements. As I mentioned before, robots can teleoperate while completing a task. So you can mix different game mechanics it's recommended when designing games to don't put a lot of game mechanics in only one game, just because the learning capabilities that the human brain has, so it's certainly limited. So we cannot learn that fast, in only one simple game. We cannot learn, I don't know, 10 game mechanics. That might create frustration in the game, and that's not a pleasant experience. So it's recommended to just start, working with one game mechanic, and sometimes you can eventually add an extra game mechanic to it. Maybe, the best games that you probably might recall that you have played, if you go and deconstruct the game, you will see that there's 1, 2, maximum 3 game mechanics on it, no more than that. And there's a lot of technological aspects that the games and the robots can share. So it's not like, if the robot has already a sensor to record the facial expression, the game cannot use that to foster the interactions or enhance the gameplay. So I highly recommend this mixture between game technology and robot technology to provide very useful and enjoyable user experiences. To finish this presentation, I would like to do some highlights of the taxonomy. So, of course, I started doing this as a taxonomy for multiplayer games, but that can also be extended to single-player games. And it's just because of what I explained before is, the most complex scenario is the multiplayer. There's a lot of small elements that you can use in single-player games as well, as you were noticing. Maybe there's some individual elements of the multiplayer that are not necessarily well structured when it comes to single-player games. For instance, the collaboration among players. So of course you can collaborate with the robot, but there's some specific games that might require collaboration with human-like intelligence that is going to be more complex to do. So, and that was actually some of the critics from the reviewers of the paper, like, why do you decide to use multiplayer? The category it seems to be very knowledgeable also in terms of single player. So the taxonomy is certainly flexible. We did it for multiplayer, but that can be also applied to a single player. I believe this, we believe this taxonomy is the first in its kind, because when we notice all the taxonomies in the HRI community or the game design community, there's no one, any of those taxonomies are not certainly proposing a comprehensive categorization that merges both elements of the robot and the game. So we believe also the taxonomy is unique. And I also believe this is a to be continued work, since this is, just it took like 1 year to review all the papers and to came across with this taxonomy, and a lot of interactive design with Kirsten, and then that was super good to have her on board, just because she has a lot of good knowledge about these different categories, and she has been also doing a lot of playful scenarios on it. So, but there's plenty of other things to do. For instance, how different is this taxonomy to a taxonomy that you can have for, in this case, not physically embodied robots, but virtual agents? How different that would be a taxonomy for that? What about specific elements like the game story of the game aesthetics? So I didn't mention all of those here, just because I didn't manage to deconstruct from the games that I found in the literature those elements that are also very important when it comes to providing very enjoyable and fun experiences using games. And what about emerging gameplay, which means, as game designers, we create a game with a specific goal that we hope is going to generate experience. But sometimes, the players, they just might come and they just might start doing their own thing in the game without caring about, what is the goal of the game. So that's called emerging gameplay. And there's plenty of opportunity in HRI and games to create this emerging gameplay. As future work, I'm planning to do something taking advantage of all the social robots we have here in the laboratory with Kirsten. I think we have a list of at least, I think, 10 to 12 social robotic platforms. So I'm gonna take advantage of that. I'm gonna try to map the game mechanics that I know that are interesting and the ones that we found here, plus others, to the individual robots, to be able to say, like, if I have this robot in my laboratory and I have to create a game, so which are the game mechanics that are probably most suitable? considering the capabilities of these robots. So that's something that I'm planning to do this year. We're also, from the ones having probably some background in business, there's something that is called the Canvas business model, created by Alexander Osterwart, which is basically, it's like a table, it's like a small table, it's like a management tool, which has like, all the crucial elements that you need to define in your business when you're starting, like, the chain, like the customers and like the added value. So we're together with Professor Jennifer Boger, and Shruti Chandra, we're trying to create a canvas for this, in which, if you are starting a game, you can just go to this specific canvas that you can identify which are the elements of the game that you would like to create to facilitate the management and communication, across disciplines. I'm coming from the field of human-computer interaction, and actually a lot of the research I do is using physiological signals as a way to create closed loops and as a way to create system awareness, so system intelligence, based on the interpretation of those physiological signals, workload, stress, cardiovascular reactivity. So I'm planning to also, and together with a master's student here, we are trying to create a library that is capable to empower robots with this physiological awareness. And we're doing some use cases to create robots that can use games that are aware of our physiological responses and can react accordingly. So the library is called HRI Physiolab, which is recently published also a paper on the framework if you guys are interested. And I'm also trying to do a use case of using Pepper the robot to foster interactions across multiple generations. And I found this, although it's a very complex scenario to create games, because you have different targets. You have a target that is very different. Older adults, for instance, versus children, they are very different in terms of how they enjoy games. I found there's like a very meaningful, the robots can play a really meaningful role here in connecting those two generations, just because all the capabilities that a robot might have. Finally, I certainly believe, and this is more like my vision in this convergence, that games can be used as a vehicle to create meaningful interactions with social robots, which is something that I sometimes miss when I see some specific examples of using robots. So there's always this question: why do you need a robot for that? I truly believe that games, once you connect a social robot with a game, that's actually creating a very meaningful interaction, because the robot itself is the one mediating the interaction. The playful robots can be a certain way to foster that interaction between human players and robotic systems. But to do that, I believe that we need a more cohesive and transdisciplinary and certainly consistent conversation between HRI researchers and game designers. So that's why, and also players, that's why I was also super happy to receive this invitation and to bring all of this tutorial in an HRI conference and venue as well, which I hope is going to help a little bit to do a lot of cross-disciplinary research. So I did this together with Kirsten Dottingham. We were checking the papers and reviewing the taxonomy and iterating this, and I think it was super helpful to have her on board. And yeah, if you have any specific question, feel free to visit us